f of x plus h is equal to f of x plus h into f dash of x, or f of x plus delta x is equal to f of x plus delta x into f dash of x. X is equal to 1 and x is equal to minus 1 are called critical points. Delta v is equal to dv divided by dx into delta x. If f of c is greater than f of x, then the function will have the maximum value. If f of c is less than f of x, then the function will have a minimum value. Hello dear students, welcome to this session of mathematics revision class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to discuss regarding very important concept, that is 3 mark questions from approximations, finding the approximate value, correct to 2 or 3 decimal places, and maxima and minima. Now, let us come to the first concept. Today, I am going to discuss regarding the revision of this approximation as well as the maxima and minima. Now, let us come to the approximation. So, in this, you may expect one small question, finding the approximate value of square root or cube root of any number correct to 2 or 3 decimal places. Very simple concept. Suppose if f from d to r, where d is a subset of r, be a given function, let y is equal to f of x is a function, let delta x be the small change or increment in x, and delta y is small change in y, and so the small change in x and y is denoted as delta x and delta y. If delta y is equal to f of x plus delta x minus f of x, dy is equal to dy by dx of delta x, or dy is equal to f dash x into dx. So dy is also equal to f dash x into delta x. So therefore f of x plus delta x is equal to f of x plus delta x into f dash of x. This is the formula which we are going to use. So f of x plus delta x is equal to f of x plus delta x into f dash x. So this is, or you can also write f of x plus h is equal to f of x plus h into f dash of x is the formula we are going to use to find the approximate value. What is the formula? F of x plus h is equal to f of x plus h into f dash of x, or f of x plus delta x is equal to f of x plus delta x into f dash of x. That's it. Now let us come to a small problem. Now using differential, find the approximate value of square root of 36.6 up to 3 decimal places. This is a problem given. So what is the problem given? Square root of 36.6 up to 3 decimal place. Given root of 36.6. Now let us consider, let f of x is equal to root x. Now here f of x is equal to root x. Let us consider f of x is root x. Differentiate this. F dash x is equal to differentiation of root x is 1 over 2 root x. Okay. Now what is given here? Let us consider this as x plus h is equal to 36.6. So x is equal to 36 and h is equal to 0.6. So now what is the formula we are going to use? F of x plus h is equal to f of x plus h into f dash of x. This is the formula. So f of x plus h is equal to f of x plus h into f dash of x. So that is root of 36.6 is equal to root f of x, root of 36 plus h is 0.6 into f dash of x is 1 over 2 root x is nothing but 36. That's it. See here, 36.6 under root is equal to f of x. F of x is nothing but root of x, that is root 36, plus h is 0.6 into f dash of x is 1 over 2 root x. So if you want, you can also write like this. F of x plus h is equal to f of x root x plus h into 1 over 2 root x. Now put x is equal to 36. That's it. So that is square root of 36.6 is equal to root of 36 plus 0.6 into this. So this is equal to square root of 36 is 6 plus 0.6 into 1 over 2 into square root of 36 is 6. So this is equal to 6 plus 0.6 divided by 6 to the 12. Now simplify this, that's it. Now this can be written as 6 plus 0.6 divided by 12 is nothing but 0.05. If you add 6.05 approximately. So, therefore, square root of 36.6 is equal to 6.05 approximately. That's it. Okay. So, therefore, the approximate value of this is equal to 6.050, correct to 3 decimal places. Now, let us come to the next problem. Same type. Use differentials to find the approximate value of 49.5. So, here what is given? Square root of 49.5. Let x is equal to 49 and h is equal to 0.5. This is f of x plus h. F of x plus h is equal to 49.5. So, f of x is equal to root x and f dash of x is equal to 1 over 2 root x. Now, what is the formula? F of x plus h is equal to f of x plus h into f dash of x. So, this is nothing but square root of 49.5 is equal to f of x is root x plus h into f dash x is 1 over 2 root x. So, root of what is x? X is equal to 49 plus h is 0.5 into 1 over 2 into root of 49. So, 49 is 7 plus 0.5 into 1 over 2 into 7. So, that is equal to, this is equal to 7 plus 0.5 divided by 7 2s are 14. That's it. Simplify this, you will get the answer. Now, if you divide this, what you will get? 7 plus 0.5 divided by this is 0.036. 7 plus this is 7.036 approximately. So, therefore, square root of 49.5 correct to 3 decimal places is 7.036 approximately. That's it. Let us take x is equal to 49. The nearest square root value is 49 and h is equal to difference is 0.5. Since this is of the form f of x is equal to root x, differentiation of root x is 1 over 2 root x. Now, what is the formula? F of x plus h is equal to f of x plus h into f dash of x. What is x plus h is square root of 49.5 is root x plus h into 1 over 2 root x. Square root of 49 is 7, which is 0.5 into 1 by 2 into 7 is 14. 0.5 by 14 is equal to 0.036 plus 7 is equal to 7.036. So, the approximate value of this is 7.036. That's it. Okay. Now, let us come to the next problem. Use differential to find the approximate value of 25 to the power of 1 by 3. Now, same here. What is given? X plus h. X plus h is equal to 25. Now, let us consider f of x is equal to cube root of x and f dash of x. So, this is nothing but x to the power of 1 by 3, 1 over 3 x to the power of 1 by 3 minus 1, 1 over 3 x to the power of 1 minus 3 divided by 3. This is 1 over 3 x to the power of minus 2 by 3, or bring this to the denominator. So, f dash of x can also be written as 1 over 3 x to the power of 2 by 3. This is the derivative. Now, since what is given 25, the nearest cube for 25 is, we can take x is equal to 27 because 27 can be written as 3 cube. 3 3s are 9, 9 3s are 27. So, if it is square root, nearest square root value. If it is cube root, nearest cube value is 27. So, and what is h here? So, we have taken 2 x's, h is equal to minus 2. H is equal to minus 2. So, 27 minus 2 is 25. Okay. Now, what is the formula? F of x plus h is equal to f of x plus h into f dash of x. So, this is nothing but f of x plus cube root of 25 is equal to f cube root of f of x is 27 plus h is minus 2 into 1 over this f dash of x is nothing but 3 into x to the power of 2 by 3. So, cube root of 27 is 3 plus minus 2 into 1 over 3 times this x. What is x? X is nothing but 27. This 27 can also be written as 3 cube. So, this is 3 cube whole to the power of 2 by 3. 3 gets cancelled. 3 minus 2 divided by 3 into 3 square is 9. This is 3 minus 2 by 9 3s are 27. 3 minus 2 by 27. Okay, simplify this, you will get the answer. So if you simplify this, this is equal to 3 minus 0.074. So 2 by 27 is nothing but 0.074. So if you subtract, this is equal to 2.925 approximately, or this can also be written as 2.926 approximately. That's it. Okay, let's come to the next problem. Find the approximate change in volume of a cube of side x meter caused by the increase in the side by 3%. Volume of a cube now of side x, so each side is x caused by the increase by 3%. Now let the volume of the cube V is equal to x cube. Now what is given? Given 3% of x. 3% of x is equal to 3 by 100 into x. That is nothing but 0.03x. Okay, this is given. Now differentiate with respect to x. Differentiating with respect to x. dv by dx is equal to 3x square. Now the change in volume is given by change in volume. The change in volume is given by delta V. So this delta V is equal to dV by dx into delta x. Okay, that is delta V is equal to dV divided by dx into delta x. What is dV by dx? 3x square. Okay, into what is delta x? This is delta x, the small change, 0.03x. That's it. So if you simplify, 3 into 0.03, 0.09 x square into x is x cube. So 0.09 x cube. So the small change is 0.09 x cube. What is the unit? Unit is meter cube. That's it. So the approximate change in the side x of the cube whenever it is increased by 3% is 0.09 x cube meter cube. That's it. Approximate change in volume is 0.09 x cube meter cube. That's it. Okay. Now let's come to the next concept. The last is the maxima and minima. You might have been studied maxima and minima. So you will get one 3 marks question and one 5 marks question from this. Now the concept of derivative is used to calculate the maximum or minimum value of the various function. Now let us consider a function. Let f be the function defined an interval I of f. F is said to have a maximum value in I if there exists a point C in I such that f of c is greater than f of x, where for all x belongs to I. That means the number f of c is called the maximum value of f in I. F is said to have the minimum value in I if there exists a point f of c is less than f of x. If f of c is greater than f of x, then the function will have the maximum value. If f of c is less than f of x, then the function will have a minimum value in the interval I. So for the function to be maxima or minima, f dash of x is equal to 0. So if f of c is greater than f of x, then it will have a maximum value. If it is less than f of x, then it will have a minimum value. So let us come to the problem. Find all the points of local maxima and local minima of the function f given by f of x is equal to x cube minus 3x plus 3. Now what is given? F of x is equal to x cube minus 3x plus 3. Differentiate this. F dash of x is equal to 3x square minus 3. Okay. For the function to be maxima or minima, f dash of x is equal to 0. That is 3x square minus 3 is equal to 0. 3x square is equal to 3. X square is equal to 3 by 3 is equal to 1. X is equal to plus or minus 1. Okay. So therefore, x is equal to 1 and x is equal to minus 1 are called critical points. Now use first derivative test to verify. Now when x is equal to 1, what is f dash of x? So f dash x is 0. That means f dash x is greater than 0. F dash x is greater than 0. That is, therefore the function is f of x, the function is minimum by first derivative test at x is equal to 1. So therefore the function is minimum at x is equal to 1 by first derivative test. Now put x is equal to 1 in the function, given function f of x is equal to x cube minus 3x plus 3. If you put x is equal to 1, then this is f of 1 is equal to 1 minus 3 plus 3, that's equal to 1. When x is equal to minus 1, when x is equal to minus 1, f dash x is less than 0. So therefore f of x is maximum. Therefore f of x is maximum at x is equal to minus 1. So the local, this is by first derivative test. Now the maximum value is got by putting x is equal to minus 1 in the given equation, this equation. So f of minus 1 is equal to minus 1 cube is minus 1, minus into minus 3 plus 3, that's equal to 6 minus 1 is equal to 5. So therefore the maximum value, so therefore maximum value is equal to 5 and the minimum value is equal to 1. These are the local maximum and minimum value of this given function. Okay. Okay, now let us come to the next very important problem. This is very important type problem. Find two numbers. We have to find two numbers whose sum is 24 and whose product is as large as possible. So you may expect this type of questions for the point of examination for 3 marks. Now what is given? The sum of two numbers is 24 and the product is as large as possible. Now let us consider the two numbers as x and y. What is given? X plus y is equal to 24. That's it. Now let us consider two numbers. Let x and y be the two numbers. If x and y be two numbers, then what is given? Given x plus y is equal to 24. Then y is equal to 24 minus x. Okay. Now the product, what is given? Product. Let us consider the product. Product a is equal to x into y. That is a is equal to x into y is 24 minus x. So therefore a is equal to 24x minus x square. Now differentiate this with respect to x. Differentiating with respect to x, dA by dx is equal to 24 minus 2x. Differentiate again, d square a by dx square is equal to minus 2. That means negative. That means the function is maximum. That's it. Very simple. Differentiate dA by dx is 24 minus 2x. Second derivative, differentiation of 24 is 0. Minus 2 into x is minus 2. So that means d square a by dx square is negative, means definitely the function is maximum. So for the function to be, therefore for the function to be maximum or minimum, here dA by dx is equal to 0. That is f dash of x is equal to 0 means dA by dx is equal to 0. What is dA by dx? That is nothing but 24 minus 2x is equal to 0. 24 is equal to 2x. X is equal to 24 by 2 is equal to 12. So one value of x is equal to 12. So when x is equal to 12, dA by dx is equal to 0 and d square a by dx square is equal to negative. Therefore the function is maximum at x is equal to 12. Now when x is equal to 12, what is the value of y? Y is equal to, what is y? 24 minus x. 24 minus x, that is 24 minus 12, that is equal to 12. So when x is equal to 12, y is also equal to 12. So therefore the two numbers are 12 and 12. So x is equal to 12 and y is equal to 12. So the two numbers are 12. If you add 12 plus 12 is 24 and the product is 12 into 12 is 144, which is the maximum value. That's it. Okay. Very important problem indeed. Now next problem. Find the two positive numbers x and y such that x plus y is equal to 60. The sum of two numbers is 60 and the product x into y cube is maximum. Now what is given? Given the sum of two numbers, given if x and y are two numbers, x plus y is equal to 60. Now just find out the value of x. X is equal to 60 minus y. Now what is given? Let us consider this as p is equal to x y cube. P is equal to this y cube as it is. Substitute the value of x, that is 60 minus y. So therefore this can be written as 60 y cube minus y to the power of 4. Now differentiate with respect to y. Now dp by dy is equal to 60 into this is 3y square minus 4y cube. Differentiate again, d square p by dy square is equal to 180 into 2y minus 12y square. This is 360y minus 12y square. Okay. For the function to be maxima or minima, what is the condition? dp by dy is equal to 0. That is, what is dp by dy? 180y square minus 4y cube is equal to 0. That is 180y square is equal to 4y cube. Divide by y square, what you will get? 180 is equal to 4y. So therefore y is equal to 180 by 4 is 45. So y is equal to 45. So when y is equal to 45, at y is equal to 45, dp by dy is equal to 0, d square p by dy square is equal to negative. If you want, substitute here. So what is d square p by dy square? D square p by dy square is equal to 360 into y, that is 45, minus 12 into 45 square. Definitely this is a negative. Therefore the function is maximum at y is equal to 45. Now when y is equal to 45, find out the other value. What is the given condition? X plus y is equal to 60. So therefore x is equal to 60 minus y, that is 60 minus 45, that's equal to 15. X is equal to 15. So therefore the two numbers are x is equal to 15 and y is equal to 45. So these are the two numbers. The two numbers are 15 and 45. So that the sum is 45 plus 15 is equal to 60, and xy cube, x into 15 into 45 whole cube is maximum. That's it. Okay. Hope you followed this. Now let us come to the next problem. Find two positive numbers whose sum is 15, sum of whose squares is minimum. So we have to find two positive numbers whose sum is 15 and the sum of the squares is minimum. Now let us consider, let x be the one number, let x be one number, then the other number will be, other number is 15 minus x. Now let us consider two positive numbers whose sum is 15 and sum of whose squares given. Let us consider sum of the squares. S is equal to x square plus 15 minus x square. Sum of the squares of first and second term, s is equal to x square plus 15 minus x square. Differentiate this. Differentiating with respect to x. So what you will get? ds by dx is equal to differentiation of x square is 2x. This is 2 into 15 minus x into differentiation of x is 1. Now multiply this. This is 2x plus into minus, minus 15 into 2 is 30, minus into minus plus 2x. So this is nothing but 4x minus 30. Differentiate this again. If you differentiate, what you will get? d square s by dx square is equal to 4x into 1 is 4x. Say for the function to be maxima or minima, for the function to be maximum or minimum, to be maxima or minima, ds by dx is equal to 0. That is this 4x minus 30. 4x minus 30 is equal to 0. 4x is equal to 30. X is equal to 30 divided by 4 means 15 by 2. So x is equal to 15 by 2. When x is equal to 15 by 2, first and second derivative test, this ds by dx is equal to 0 whereas d square s by dx square, d square s by dx square, this is positive. Positive. Therefore, the function is minimum. Since d square s by d square s by dx square is positive, therefore the function is minimum at x is equal to 15 by 2. So therefore, when x is equal to 15 by 2, the other number will be, other number is, what is the other number we have taken? 15 minus 15 by 2. Take LCM, 2 is LCM, 30 minus 15, that is also equal to 15 by 2. So therefore, the two numbers are 15 by 2 and 15 by 2. That's it. This is very important and simple problem for 3 marks. So therefore, the two numbers are 15 by 2 and 15 by 2. If you add 15 by 2 plus 15 by 2 is 30 by 2 is 30 by 2 is 15 you will get. That is sum of two numbers is 30 and whose squares, sum of their squares is minimum. That's it. Okay. Now these are few problems based on this. Now let us come to the next problem. The 5-marker question will be like this. Show that the maximum rectangle that can be inscribed in a circle of radius a of square of side is a root 2. So the maximum rectangle, the rectangle that can be inscribed in a circle of radius a is a square of side a by root 2. Now let us consider a circle with O as center and a is the radius of the circle. Then let us give the points as P, Q, R, S is the rectangle. That let 2x and 2y be the dimensions of the rectangle. Okay, A is the radius. So let 2x and 2y be the dimensions of the rectangle. So therefore, we can write 2x square plus 2y square is equal to 2a whole square. That is 4x square plus 4y square is equal to 4a square. If you divide by 4, x square plus y square is equal to a square. Let us represent this as equation number 1. Now, since a is the area, therefore the area is equal to 2x into 2y, length into breadth, that is 4xy. Now, since what is from this, x square plus y square is equal to a square, you can take y square is equal to a square minus x square, or y is equal to root of a square minus x square. So therefore, a is equal to 4x into root of a square minus x square. Let us represent this as equation number 2. Now let us square this. Squaring on both sides, what we will get? A square is equal to 16x square into square root gets cancelled. Now let us consider this a square is equal to z. Let a square is equal to z. Okay, therefore z is equal to, what is z? 16x square into a square minus x square. Now differentiate this. Differentiating with respect to x. dz by dx is equal to first function. Differentiation of a square 0 minus x square is 2x plus second function a square minus x square into 16 as it is. Differentiation of x square is 2x. Now multiply this. 16 2s are 32. 32 x square into x is x cube plus 16 2s are 32 x into a square minus x square. Now you can take 32x out. What is left over is x square. 32 is gone. A square minus x square. So this is 32x into a square minus 2x square. Now this is dz by dx. Differentiate again. D square z by dx square is equal, again product rule, 32x into differentiation of this a square is constant minus x square is 2x, 2 into 2 is 4x plus a square minus 2x square into differentiation of this is 32. Now for the function to be maxima or minima, dz by dx is equal to 0. That is 32 times x into a square minus 2x square is equal to 0. So 32x is equal to 0, that is x is equal to 0, or a square minus 2x square is equal to 0. A square is equal to 2x square. That means x square is equal to a square by 2. X is equal to root of a square by 2. That is nothing but root of a square divided by root 2. That is nothing but plus or minus a by root 2. So x is equal to a by root 2. For the function to be maxima or minima, dz by dx is equal to 0. You will get x is equal to a by root 2. At x is equal to a by root 2, at x is equal to a by root 2, d square z by dx square is equal to negative. So therefore the function is maximum. So therefore x is equal to a by root 2. At x is equal to a by root 2, dz by dx is 0 and d square z by dx square is negative. Therefore the function is maximum. So when x is equal to a by root 2, what is y? Y is equal to root of a square minus x square. So that is nothing but root of a square minus x square is a square by 2. This is take LCM and simplify. You will get a square by 2. Y is also equal to a by root 2. So therefore, what is say? So therefore, x is equal to y is equal to a by root 2. Therefore, the maximum rectangle that can be inscribed in a circle of radius a is a square. It's a square of radius a by root 2. So since x is equal to a by root 2, y is equal to a by, all sides are equal means then it is a square. So therefore the maximum rectangle that can be inscribed in a circle, hence the maximum rectangle that can be inscribed in a circle of radius a is x is equal to a by root 2, y is equal to a by root 2. Therefore the rectangle is a square. That's the problem. So hope you may expect this question for 6 marks. Okay. Now that's all regarding this session and the application of derivative. Let us meet with the next concept, integration, in the next session. Thank you very much.